Good afternoon, everyone. I would like to talk about commercial vehicles a little bit and do some setup here. So my name is Carlton Bale, and I work for Cummins. And for those of you who aren't familiar, we are the largest powertrain Tier 1 globally. Not as much presence in Europe, but certainly in China, India, South America, North America. But we'd like to do some background on commercial vehicle, just so you have an idea. So I'll have some company details there on the line, but Kai, if you just want to go through the slide and populate it. So we are focused mostly on diesel engines, but also hybrid and battery as well. But really, when we talk about commercial vehicles, it's not just trucks. We also have construction and mining and power generation and numerous applications. So what that means as a Tier 1, we work with literally hundreds of OEMs. So our portability problems and reusability problems are magnified compared to automotive. But also, we have a lot lower volumes. So each one of these OEMs has significantly lower volumes. So we can't really scale these investments across a lot of different types of vehicles. And also, our customers, their number one driver is going to be what is the lowest cost. So we can't adopt newer technologies as quickly because the adoption is higher and the ROI may not be apparent. So we really get pushback from our customers as well. So what that means is higher variation and lower scale. So with that, I'm going to pull up, this is an old slide, but really, for the past 4 years, our objectives are still the same. The first is because we have so many different OEMs that we work with, we need portability. And it's not just us, the industry needs this. Even as an OEM moves from one platform to the other, or from one region to another, we want the applications to be portable. We need a way to update these applications over time. And because we're slower to adopt new technologies, CAN is going to be around for a long time as a primary communications for embedded ECUs. So we have to figure out how to standardize and secure the CAN access. So with these in mind, we're here to announce this week the kickoff of a commercial vehicle focus group. And really we're going to have the kickoff tomorrow in a meeting, and also we're going to have a follow-up kickoff at OCX. And what we're going to do is just to first start off with use cases. So what are the use cases that we as commercial vehicle participants want to solve through open collaboration? And then we'll develop blueprints for that, and then we'll start to bring in the open source pieces and collaborate within those projects to close the gaps. So the use case we're going to talk about today is how do we update an embedded ECU software over CAN through an open source stack. We have some other use cases here that we think could be focused in the future, but really it's going to be the community collaboration that defines those other use cases. So with that, I'm going to turn it over to Kai and Daniel to talk about what we're doing as a proof of concept. This is a collaboration between Cummins, Allison Transmission, Microsoft has helped us a little bit, and with ETAS.
Right, can you hear me? Good. I'm just going to be showing you a couple of pictures to bridge between the what and the goal and the problem that Carlton was talking about, and Kai actually showing you what we built end of last year to kind of, give a foundation potentially for the SIG and something to look at and discuss and to tear apart and maybe rebuild. This is the demographics slide. So who was there in the 80s? Come on, date yourself. And this is not surprising. There's nothing new here. There's nothing new in the next couple of slides. But essentially, how did we actually make software scale and reusable across different devices, right? We've been there in the 80s. We've been there in the 2000s, 2010s. I guess most people now would raise their hands for this revolution. For some reason, we think it's perfectly fine today that we have dozens of vehicle brands and models with dozens of generations, and everything is different, and people who actually need to scale and deploy generic business logic across more than one of them are essentially out of luck, right? That's apparently today the state of the art. the simple idea is, can we maybe at least partially, and for some segments of this industry, change that, right? Because again, Carlton was motivating one reason why it might be useful not to have to reinvent every wheel all the time for every vehicle. In my mind, this is the heart of what this SDV thing is about, and that is the heart of what we in this community and others as well have been aiming for and building in the last couple of years. Jump off to towards the actual blueprint and demo section. But essentially, if you want to go from that left side to the right side on the slide, on the picture we just saw, you need to generalize and align on basic capabilities that an IT system has. Again, this isn't new. Everybody here probably has heard that for like 20 years now, or maybe 40. So there's no surprises anywhere, which is why it's surprising that we just don't really get anywhere here. But I'm trying to map a few of the high-level capabilities to what's been going on in the Eclipse SDV ecosystem and others. So software deployment, configuration management, we have Symphony, we have Ankaios. We've heard good things about Ankaios today already. Execution management, we have systemd, we have Eclipse BlueG, we have heard about Tampani today. Communication abstraction service mesh, because once you have a heterogeneous landscape of nodes and devices, each running a different software stack, well, maybe it's useful if they still can communicate. Maybe it's useful if you don't have to reinvent that communication layer every other year. That's where we get stuff like uProtocol as a universal service mesh. On the bottom half of this, essentially the domain specialized capabilities, right? I mean, it's nice to run software in a device. It's useful if the software actually has any touching points with the device and with the domain. We do have things here for many years now. We have the data catalog definition out of Kvisa, the VSS spec, plus whatever else has been built on top of that since. And we have Kuxa, that's been mentioned multiple times today already, which is PubSub data broker integration point for that kind of data. We are now seeing code drops end of last year and things that are beginning to be usable in the context of the S-Core project, specifically Eclipse Open SOVD as an open implementation of a standardized diagnostics API. So there's two data paths and interaction paths with your device right there in our ecosystem. And what we have a few starting points in, but which is probably the biggest, area of potential going forward is where those two domains meet. I mean, like one thing that Android did that Linux didn't do is be very, very aware of power management on a device, on a mobile device with a small battery. And I don't think that this extreme level of power management is probably our top goal in an EV, but there is something here around power management, around state management. Pulpiri, Tampani might actually fit that space very nicely, but at least in my mind, this is like the mostly uncharted area for now. But anyways, that is, again, that's what's the interlude, not very taxing, I hope, but that is essentially the background for how we are getting from the problem statement that Carlton made to using the pieces that have been built in this community, to get to something that might actually be a real SDV stack. And now I'll shut up and let Kai show you what has been done.
So the first thing that I want to do is start up the Docker Compose setup. We have implemented quite a few services as container images, and we are orchestrating them using Docker Compose. This should, of course, in a real-world example, be replaced with something like Ankaios or even Pulpiri or whatever. But I'll start this up. In the background, you see it's a kind of a list. And then while we wait for that to start up, I'll go back to the architecture diagram that we have. So the use case that Carlton spoke about was the updating of an ECU over a CAN bus. And we had been talking about this, I think, for over a year. And Cummins even started a dedicated Eclipse project called Canode for exactly this purpose, trying to provide an abstraction of a CAN access API, if you will, because the problem that they are struggling with is they need to do this in a new context wherever their technology gets deployed. Each OEM has their own way of providing access to the CAN bus that they need in order to perform a firmware update. This goes so far as they implement a TCU, their own black box that connects back to their cloud system to download a firmware image and then do the firmware update process. And you need to do this for each and every OEM that you integrate with. And the overall idea now is, hey, can we have a standard software architecture that allows us to just implement the software update functionality as a container, and then deploy that in a runtime environment that provides some standard APIs that we can leverage in order to do what we need to do. And this POC is kind of an example of how this might actually look like. A runtime environment, in this case based on Docker, but it can be any container runtime, and some other components that provide standard APIs that are useful in this context. And so the first use case here is the ECU update use case, and this is implemented along this line here. So you would, for example, have an Eclipse Symphony server running in a backend in a cloud off vehicle, from where you trigger a firmware update for one of the ECUs. And in the vehicle, you have an Eclipse Symphony agent that is able to get this information from the cloud and forwards this information by means of the Eclipse Symphony target provider for U protocol to a service, a U protocol service that is implemented to get the information about which firmware needs to be updated for which ECU. Then this information is processed, extracted from the message, and then inside of this component, some logic would run in the real world that would reach out to the Cummins backend, retrieve the firmware, parameterize it with the local environment necessary to make it work inside of the concrete vehicle, and then start the update process over the CAN bus. So in the past, this was exactly what happened in this black box in the TCU. But now the idea is, okay, can we find a standard way of accessing the CAN bus to actually transfer the firmware image to the ECU? And this is where OpenSOVD, or better, the SOVD standard comes into place, because it has or defines a component called the classic diagnostic adapter, is that right? Which is supposed to provide exactly that, the abstraction of classic diagnostic infrastructure, which is usually based on UDS over CAN or IP. It doesn't really matter. But the idea is, it is always the same API. In this case, the API is the SOVD API, which is an HTTP-based API. So all of a sudden, if this becomes a reality, you can implement one component that installs the firmware over DOIP, CAN, proprietary CAN, UDS over CAN, no matter how the access to the CAN bus is actually implemented, as long as the OEM or the runtime environment contains this SOVD CDA component. And this is actually something that the Eclipse OpenSOVD project is implementing, and which we have leveraged at a very low level, just as a POC to illustrate how this can actually work. Sadly but truly, we were not able to employ this for the firmware update yet, because our friends at Cummins are still working on migrating their existing functionality to adapting it to the SOVD API. But right next to it, you see another use case that is implemented. This is about the external configuration of the transmission mode in a vehicle. So the transmission that is located in the truck, for example, can be set to different runtime modes, like performance, economy, something like that. This is a very abstract concept, economy, performance, but for each and every transmission, it results into different things that need to be done. For example, for some it might mean you send a particular frame over the CAN bus. For others, it means you invoke a UDS operation, whatnot. So the idea, again, is abstraction, in this case by means of defining a U service, a U protocol service, that has an abstract service operation, set transmission mode, and has an enumeration of potential values. So a client can interact with this service no matter what transmission is in the vehicle or how it is actually accessed. So in this case, again, this is a U protocol service. It is a few lines of code on top of U protocol. And the implementation of the service is actually an HTTP client that interacts with the SOVD API in order to invoke a UDS operation. And that is implemented in a simulated ECU where a UDS stack, a DOIP stack, actually runs and which is able to process the incoming requests and respond with a corresponding message. And then on the right-hand side, we have a third use case, which is about in a back-end fleet management system, you will need to know things about the vehicles that are out there. You will need to know about the particular parts that are in there, the type of transmission in there, the modes that it actually supports, so that from the outside you can set it to an appropriate mode instead of just an arbitrary mode. And in this case, we decided to, again, implement a U protocol service that is a client to an Eclipse CUXA data broker, which reads all of these properties from its Covisa VSS tree, and then sends the results periodically to the backend, encoded in a JSON message so that it can be processed there in any arbitrary way. And yeah, let's hope that the system has started up. We can check if it did by checking the log files here. So we have containers here, we have the CUXA data broker, these are the log files. We have the powertrain service, which is available. It's running on this address. We have the Symphony agent. We have the ECU updater, which is able to do the ECU update. And these are basically simulated services. I can now start some clients that are actually interacting with these. So, for example, we can trigger an ECU update. So what this now did, it just issued a request to the Symphony API in the backend. The Symphony backend server forwarded the request into the vehicle, and there it got processed by the ECU updater. And that is something that we should be able to see here. So yeah, we are now installing the firmware for the engine controller and for the telematics unit. We should also be able to see this having happened in the Symphony agent, where we see a lot of messages which I have no clue what they mean. Heishi from Microsoft is sadly not here today to tell us about it, but this is in fact going through Symphony and then into this U service. So this is the ECU updating use case. If we continue here, then it should be uninstalled again. So that is what you see here. The corresponding message has been processed and it's now removing. So in reality, this would now result into the SOVD API being invoked multiple times in order to transfer the firmware image to the ECU and then finally rebooting it. And you would see this in here in the future as well. So the other use cases are implemented as a small command line tool. This is a Rust client. The parameter MQTT is interesting here. It means we use MQTT as a transport. We could also use Zeno, for example, as a transport. U protocol is agnostic of the transport. I think earlier today we saw what we needed to provide would be a NATS transport in order to make it interoperable with Nexus. That is shouldn't be too hard actually. It's one layer in the architecture of U protocol implementing that for NATS, and then we could also use NATS here. So for now we are connecting. Now it says setting the powertrain mode to economy. This is the data that we receive from the CUXA data broker. This is static data. It has been configured during the startup of the CUXA data broker. You wouldn't expect the VIN to change over time, hopefully, or the brand or the model of the truck. But the powertrain mode, however, is always switched between performance and economy. And you can also see this happening in the ECU simulator, where you should see periodic messages here where it is always flipping. Set transfer powertrain mode 1, 2, 1, 2, 1, 2, always vice versa. So
those tools, just for context, the CDA and the ECU sim, those are artifacts, things built by the OpenSOVD project. We run the classic diagnostic adapter, vanilla, like they build it, and I did a little customizing of the ECU simulation. Again, it's extremely simplistic, but it does the job like it pretends to be an ECU receiving those bytes, sending back response bytes, and the whole system conceptually behaves as if there was a powertrain ECU here or transmission ECU being mode switched.
Yeah. So this is actually pretty interesting. The overall message, the UDS message, is 3 bytes, I think. And we're doing a good job to turning this into a 1 kilobyte HTTP request response transfer, but why not if we can? Yeah. Okay. So this is basically it. Not much magic happening. The data broker, nothing to see here. Vehicle properties service. This is also logging the messages that it is receiving from the data broker, and coming back to the overall architecture. This is what we have done so far. The open SOVD or the SOVD architecture itself would allow for a different architecture though, and we played around with these a little. One alternative would be not to have the ECU updater as a client to the SOVD API, but instead be implemented as an SOVD server itself. So the API would not be uProtocol, but it would expose the same API, the SOVD API, in particular the resources required for doing the firmware update itself, so that any other client could simply orchestrate this firmware update using a standard API if uProtocol is not desirable in this case. Another option yet would be to implement the ECU update as a plugin running inside of the open SOVD server. This would then allow the usage of a different type of update process. So SOVD allows to do these updates in 2 different ways. One is controlled and managed by a client that invokes uses several requests to start the update, to check for the installation of the files or download of the files, and then finally doing a reboot and stuff. Or to just simply check whether there is an update available, and then if it is, doing one HTTP request to trigger the update, and then this component would be responsible for doing the overall process and would only answer to requests for retrieving the current status of the update process that a client could then use. So these are different options. We are currently not really thinking of implementing this, but in particular because we simply have no clue which of these architectures is more appropriate than over the other. Unless somebody actually uses the technology and starts playing around with it and making experience, it will be hard to see what we should favor in this case. But yeah, this is where our thoughts are going.
But what you can see is essentially tying this back to the slides and what we talked about earlier, right? We have a little small, but a little landscape of IT business level services with well-defined, easily accessible fixed APIs. How you access them, transport protocol, etc., doesn't really matter because we abstract that stuff away. And there exist well-defined and extensible touch points into the vehicle. Like, you see the Cummins ECU down there at the bottom. I mean, that is where a lot of the work will go if this gets productized, of course, right? But the point is where that work would need to go, what kind of work would need to happen, that's kind of obvious now. And let's see what happens in the commercial vehicle SIG that we are proposing, but one of the ideas is to take that, again, tear it apart, rebuild it in whatever way we want, but make that a starting point for whatever comes out of that group. Because again, I believe this allows you to do essentially almost everything that we have been talking about for the last 10 years. So let's see how far we can take it.
And this is basically it. So if there are any questions, we'll be happy to answer.
Questions? Yeah.
So you want to transfer that also as a SDV blueprint, or?
Yeah, exactly.
Yes, that's the overall idea. Yeah, we will create a blueprint from this. And tomorrow during the kickoff, we want to talk about what other use cases might be in there. The idea would be for this special interest group to not only talk about things that should be done, but instead use this piece of software, the blueprint, as the catalyst for evolving the whole thing, I guess.
Yeah.
Yeah, thank you for your very interesting talk. I recall the time we have been working with you also on your protocol. It's a question to Cummins. Are you actually planning to take this blueprint now and make it as a productive solution? And second, do you see any pitfalls concerning safety, basically, certification for that setup? Thank you.
Yeah, good question. So, first of all, as Kai mentioned, we do have what we call our legacy telematics approach, where we sell an engine and we will have a connectivity box mounted on the side of the engine. So we have some of these technologies in production today on our own telematics device. Now that's not really in the spirit of software-defined vehicle, right? Like you don't want multiple telematics devices. So we do hope that there is more industry adoption of this technology, which allows us to move our software from our own telematics device onto an OEM device. But to do that, we have to have OEM cooperation and we have to have some level of industry adoption as well. So, so will it become widely adopted, or will it be some different version of this blueprint that's widely adopted? We don't know. So that's where we have to get to collaboration. So I would say it's somewhat in production today, but it's nowhere near the scale it would need to be. So we're trying to figure out what that industry level solution would be. And secondly, you ask about safety criticality. And the way we handle this, all of our connectivity suite is non-safety critical. So the firmware updates, everything is handled in a non-safety critical way. So we do have domain separation. That's why the CAN communication is so critical, that it is secure and that we limit access, we limit data rates, we limit the ECUs that can be accessed. And the time when that happens. So if we have an ECU updater, it can only access a certain ECU when that software update is occurring. But really, you know, the ECU itself is what is safety critical. And it actually handles the update itself. It just receives a command telling it to do that update. So domain separation is how we address the safety criticality of that.
And this architecture would actually allow to isolate the safety relevant features in the SOVD server, I guess, or the access functionality for the CAN bus. So that would even make it easier for others to use it in a safe way. You have it once, and everybody can use it in a safe way. That would be my understanding of how this should work in the future.
Yeah, I also had a question. So I had a quick question, which is, so your title says existing open source building blocks. How much code did you have to write for that demo?
Show it.
Yeah. Was it vibe coded?
So the services themselves, these are maybe 20, 30 lines of code. The biggest work was defining the service interfaces, talking with Carlton about the domain requirements and stuff. But the code itself is trivial, really. Yeah.
So
Okay, that's the message I was hoping to
the
get.
longest, most complicated file is the Docker Compose definition, I guess.
Yeah, probably. Yeah.
Okay. Yeah, Ansgar?
And the ODX data that we wrote for the
So I just wanted to make sure that once I gave credit to our long-distance travelers from Korea, even Zara did that already. I know Berlin and Nürtingen is also quite a trip, but thanks, Carlton, to also make your way from the US. We really appreciate that as well.
He's here for the skiing.
And, sorry?
He's here for the skiing.
I see. Two questions to what you've been proposing here. You've been framing that under the tagline of commercial vehicle, but looking at those use cases, I would say they are not mandatorily attached to commercial vehicle, right? So is there a meaning also in adopting that in a non-commercial vehicle domain? That's A. And B, if you tagged it, or since you tagged it as a commercial vehicle activity, where is our recent commercial vehicle members in it?
There.
Do you want to answer that?
Sure. I mean, there is no reason why this has to be commercial vehicle. You saw my first slide that did the introduction of why it's a little more critical that we have more modularity and interoperability and similarity of stacks across different solutions. We don't have the scale or the investment capability to do what an automotive company would with that full integration and a completely new stack. So, and we move it at a slower pace. So I think the use case for commercial vehicle is easier, but there's no reason why it couldn't happen at a larger scale as well.
Yeah. My take on it is, this is an SDV use case that is at the application level. This is about why is SDV advantageous in this case. The rest of the industry, the non-commercial vehicle, are currently struggling with very low-level operating system consolidation stuff. They are not thinking about any use case. And that is why it was much easier to talk to Carlton from a truck OEM who are actually thinking about use cases and not underlying infrastructure technology. They are eager to simply adopt the technology that solves their problem instead of creating new technology that solves a problem that is already solved. That's my take.
Okay. Well, thank you, everyone. And maybe you can follow this up during coffee. Round of applause.
So we will have half an hour of coffee break, the last coffee break of this day, and the last chance for you to participate at the raffle. It will close at about 4:30. The last chance for you to participate, and we have a new QR code, which is even more smooth to get into the raffle.